Hello! Today I'm going to talk about speakers or loudspeakers. Previously we talked about microphones, and perhaps the next logical step would be to go into audio amplifiers, but we cover audio amplifiers at a different time, so I'm going to go straight from microphones into speakers. Now, a speaker is something that's going to convert voltage and current into power. Remember that power is manifested by producing either heat, mechanical motion, or electromagnetic radiation. In this case, we are producing mechanical motion by moving a speaker, which moves the air and imparts sound waves into the air. So we start with a microphone or some other audio input, go through the amplifier, and then we want to take that sound and reproduce it by moving air with the speaker. Now, a speaker can be made from anything that can convert that voltage and current into power, and there are a number of things that might do that, such as a flame or a Tesla coil. But those are more novelty speakers. They're not really useful for a good sound system. So I'm going to go into the typical loudspeaker, which is a dynamic speaker. And we'll just go right into that, because what we have with a dynamic speaker is a magnet. And I will shape that sort of like the letter E, and you will see in a moment why. So there's our magnet, and basically we have a north pole, a south pole, and a north pole. Around this magnet is a coil of wire on a support, and that goes to a diaphragm of some sort. There's a diagram of that here. It's a little more clear than my scribbling on the board. And if that looks familiar, that's because this is identical to a dynamic microphone. A dynamic microphone is optimized to pick up sound and convert that into an oscillating current, and a speaker is optimized to take an oscillating current and convert that into motion. So our speaker, let's take a look at the parts of it. As we said, there's a magnet. Usually that's a big ceramic magnet, and that's going to be mounted on some steel or soft iron. Soft iron meaning that it doesn't retain its magnetism when the magnet is pulled away. That's more permeable and carries magnetic fields a little better. And that soft iron is going to have that E shape that I'm talking about. And I'm going to draw this a little more realistically here, because the little channels in that E shape are very narrow, and inside there is a cylinder made of whatever material. It might be lacquered paper or it might be plastic, but that of course is wrapped with a coil, and that is free to move there. And so as we run current to the wires coming out of that coil, we're going to get a current going in one direction as we put in alternating current. So here is our alternating current going in. Current goes one way, then it goes the other way, back and forth and back and forth. As it goes in, we get a magnetic field which interacts with the magnet that the voice coil is suspended in, and that's going to cause that voice coil to want to go one way when the current is going one direction, and that voice coil is going to want to go the other way when the current is going in the opposite direction. So we will get an oscillation of that voice coil. Now, of course, there's a lot more to it, because if I simply had this, the first current that went in there would probably shoot the coil right out of there. But of course, there's other parts of the speaker that we need to make that work. So let's redraw that real quickly just to simplify that. So here is our magnet, or our pole piece connected to the magnet, and our voice coil is in there. I'm just going to draw it as two little lines there. That voice coil is connected to a cone of paper. Might be called the cone, might be called the diaphragm, but either way it's usually made of paper, a stiff paper. And also we have a frame around this, so this whole apparatus is mounted on a frame. Let's put that frame right here. This is usually a metal frame. And going to that metal frame, we have two supports. One is going to be in here, and that might go to some support at that point there. Notice I'm corrugating it because this particular support needs to be flexible, so it wants to hold that cone and that voice coil in the right orientation, but it needs to be able to move. This is called the spider. So that's going to hold the voice coil close to the magnet, but As we get further from the magnet, we have another support. And I'll just draw that as a little U shape here, and there's going to be some connection to it, to the frame. Once again, this might have a number of corrugations to it, but trying to make that symmetrical. This is flexible and that's flexible. The cone is fairly inflexible. The spider is flexible. This is called the surround, or sometimes called the roll, but it's usually called the surround, and it's simply a flexible support. So now we have most of our speaker here. We have the flexible support at the edge of the diaphragm or cone. We have the voice coil, which is suspended by the spider. The diaphragm or cone going between those, that is suspended inside the magnetic field. And of course, this has a wire coiled around it. Those coils will usually come out and connect to the cone, where there is a wire soldered to that. And on the outside, I'll just draw this here as a little line, but that will go to a metal connector that we can solder some other wires to. So there's actually two of those, but I'm just showing one of them. And so that's how we make the connection to the voice coil. So these are very flexible. This wire here is usually going to be a braided wire, so I'll just draw it sort of like that, a braided wire that goes there, two of them of course, and that's going to carry current to the voice coil. So that's the complete basic speaker. And of course what happens is if we put current to it, the current goes one direction, that's going to push the speaker out. Current goes the other direction, that's going to pull that speaker in. And when we get alternating current, of course, that's going to go out, and it's going to go out at the frequency of the alternating current coming in. And we usually think of alternating current as like 60 hertz or 50 hertz coming from the wall or from the mains or power grid or whatever you call it in your country. But of course, alternating current can be any frequency, and the sounds that we create when they go into a microphone create alternating currents from from a human voice for anywhere from about 100 cycles per second to maybe 3,000 cycles per second. And of course, our ears can hear from 20 cycles per second up to 20,000 cycles per second, or from 20 hertz to 20,000 hertz or 20 kilohertz. So the speaker is going to be sensitive to a range of those frequencies. I'm kind of drawing a big speaker here, which would be a woofer, which would be sensitive to your lower frequencies. And a smaller speaker would be sensitive to the higher frequencies. And there might be some differences in the construction. For example, a speaker sensitive to high frequencies, which would be called a tweeter, might have our voice coil, and there will be a little dome on it and a spider. And of course, here's our magnet. But notice what's missing is the cone. I'm taking that off again because your tweeter may or may not have a cone. It may have a small cone or no cone at all, depending on the design. So a tweeter needs to be able to move very fast to respond to frequencies up to 20 kilohertz, where a woofer needs to be large and move a lot of air, but it doesn't need to be small because it doesn't need to move as quickly. Lower frequencies won't be moving as fast as the tweeter. And of course, a complete speaker system could have a woofer and a tweeter, and maybe even something in the middle called a mid-range speaker that handles the mid-frequencies. Now, some speakers try to handle a wider range. One thing we can do here is put a bit of a support right there and have an inner cone that's smaller and have some kind of a flexible support in the right place here. And that is called a whizzer. And that would react to high frequencies. So we have the main cone that will react to low frequencies, and the whizzer that, although it's moving with the main cone, it can also react to the higher frequencies, and that will broaden the range of the speaker. And you could have a full range speaker that responds to the entire range of human hearing, although it's not going to be as efficient as using multiple speakers that I'll be getting into more detail a little bit later. So we added the whizzer cone to our diaphragm cone to the speaker to make it a wider range speaker, or maybe a full range speaker. And one other thing you'll of course find here that's kind of obvious but does have a name. It's usually curved like a dome, and that's called the dust cap. Now, the speaker will certainly work without it because it has all the support, but you don't want dust getting in there. So there's a dust cap in the middle, and of course that does move some air, so it does have some purpose, but there it is, the dust cap in the middle. And this tweeter, of course, seems to have a dust cap, but no main cone or main diaphragm such as the bigger speaker here. So as far as the construction of a speaker, I've pretty much beat that horse as much as I can beat it. So there we have it, a magnet, a coil inside the magnetic field, and that's connected to a diaphragm, also called the cone. Spider supports the cone near the magnet. The surround supports the cone near the edge. Those need to be flexible, and so the cone can move freely. We have a dust cap in the middle. We may have a whizzer cone, but that's just depends on the design if they want to try to increase the range of that speaker. And then, of course, a mid-range speaker would be smaller and made to respond to mid-range frequencies, and then the tweeter. And of course, this is called a woofer, the big speaker. A speaker that responds to some higher frequencies, but not all the way up to the highest frequencies, would be a mid-range speaker. And then the one that responds to the highest range frequencies is going to be a tweeter. And there can be some other designs for a tweeter. We'll talk about those in a moment. Now, another type of speaker that's fairly common is a horn speaker. And we can probably make one of those by getting rid of our big woofer here and just going to our little tweeter, because a horn speaker is going to have a driver, which is the part of the speaker that moves. So we don't talk about a driver in woofers and tweeters and mid-ranges unless they are a horn speaker. We may call it a driver, and the part that is the driver is pretty much a regular dynamic speaker. But this is connected to a horn which flares out. And the purpose of that is that this horn couples the speaker to the air very efficiently. It's an impedance match, actually, like I will be talking about in a moment, but it's measuring the speaker impedance to the air impedance. So it's a very efficient way to get the movement of this driver coupled to the air. Instead of having the big cone to couple, we have this horn that couples it to the air, and they can be big and they can be small. They can work with lower frequencies or high frequencies, and a lot of tweeters might actually be horn tweeters. They would be, of course, a lot smaller, made to react to higher frequencies. I'll just kind of draw that like that. And so that's not connected directly to the speakers, but it's acoustically coupled, and it takes that sound and couples it very efficiently to the air. So horn speakers are quite common. You go to a music venue or other kind of place where there's big speakers, horn speakers are ubiquitous because of their great efficiency that can get a lot of power into a lot of air. Another type of horn speaker you might see is a folded horn. That's the megaphone. One common way to see that is with a handheld megaphone. Here's a picture of one here. And sometimes they're not handheld. There's one there. And the way that is made is it's basically just another horn speaker, but I'm going to draw the profile of that here. So remember, this is the coil and driver, and we have the horn acoustically coupled to that. And we go out just a little bit there. And then there's another horn capped over that. Let's see if I can draw that here. And then on the outside of that is an even bigger horn. Okay, let's see how well I can do this. How's that look? Not too bad. So the driver couples to the air here, and it goes through the small horn, reflects off the middle horn. If you look at the folded horn, you'll see that there's that middle cone inside, and then it reflects back down to here, off the big cone, and then out. And here is an animated diagram of that in operation. So that is your folded horn speaker. One other speaker to talk about, besides the dynamic speaker, that's fairly common is a piezoelectric speaker. Remember, the piezoelectric effect is where if we distort a crystal, it's going to create a voltage, or vice versa. If we put voltage across a crystal, it's going to distort. So here's the basic diagram of that. So there's a crystal between two holders. We put a voltage across there. It's going to distort that crystal, or if we distort the crystal, it's going to create a voltage. So a piezoelectric element can act as a microphone or a speaker. Are there piezoelectric microphones? I don't know how common they are, but there are common piezoelectric speakers that are reasonably often used as a microphone. For example, if you buy an electronics kit that allows you to make all kinds of different circuits, you may find that it comes with a piezoelectric earphone, And if you make a circuit that needs a microphone, it might have you use that earphone as a microphone. Some of the Radio Shack kits came with a piezoelectric earphone that was also used as a microphone occasionally. But we're going to use this as a speaker, and usually it's used for such as earphones or headphones. How often are they used for a big speaker? Not very often, but if they are, they would be used for tweeters because they work only at high frequencies. But that's worth mentioning because that is a type of speaker that you will see occasionally. I think they're sometimes used on the motherboards of computers, but don't quote me on that. So that's your basic types of speakers, your types of your dynamic speakers, and there's not much more to say about that. There is quite a science into building them, but that's not what this is about. We're just talking about the basics here. So let's move on to the next thing, and that is speaker enclosures, because to get the most out of your speaker, you have to have it in a proper enclosure. So let's talk about the first type, and that would be a simple sealed enclosure. So we have a box and a speaker. And wires would come out, everything would be sealed, and the idea is that we don't want any air going into or out of this box. And the speaker may be designed for that. In fact, it's a type of speaker called acoustic suspension, which is specifically designed to work in a sealed box. You do want to have the box the right size because the sealing of the box limits the movement of the speaker because, of course, as the speaker moves in, it's going to compress the air, and the air is going to resist that, so it's going to resist the movement. And when it moves out, it's going to rarefy the air, and the air is going to resist that also. So it restricts the movement of the speaker, which is negative feedback. And when we talked about that in circuits, what does negative feedback do? Well, one thing it does is it broadens the frequency range. It broadens the bandwidth of the circuit. So a speaker that has a response like, here's our graph, and here's 20 hertz and 20 kilohertz. A speaker may have a response that looks something like this. And if it's an acoustic suspension speaker in a proper box, it's going to essentially pull down that response in the middle and flatten it out. And as you can see, that is therefore widening the frequency response. So it's pretty much flat from there to there, where before it was flat from, maybe there to there. So that's your acoustic suspension speaker. How common are they now? I don't know. I haven't bought speakers in a while, but back last time I bought a set of speakers and built them myself, I used acoustic suspension speakers. Next type of speaker enclosure is probably the most common. You'll very often see these in your subwoofers if you have a system that has a subwoofer, and that is a bass reflex. And I'm just going to modify this box here to become a bass reflex. So there's our speaker with its accompanying wires, and there's a tube. So what's that for? Well, as I said with the acoustic suspension speaker, the speaker is going to lose some efficiency, trading that off for bandwidth. If we put a hole in here, well, that's going to do is two things. One, it's going to allow that speaker to move more freely, so it's going to be more efficient. But one problem with that is that sound coming off the speaker is going to be one phase. So when the speaker cone is moving this way, it's going to be sucking air in. And when the speaker cone is moving this way, it's going to be pushing air out. So when the speaker is making a wave that goes this way, basically we have a wave coming out of the cone that is the opposite polarity. So if we have a sound peak, let's say we have the speakers moving that way, creating a compression wave right here. At that point, there's going to be a rarefication wave produced here. And that rarefication wave, I'll just show us some dots. They're, of course, going the same direction at the same speed, and they're going to tend to cancel each other out. However, if we put a tube there with the right design, we have to have the tube and the cabinet designed the right way. Back when this was invented, it took a lot of trial and error to get this right. Now we can use computers to design them, but you had to get it just right. The volume of the cabinet and the length of the tube and the diameter of the tube, you get it just right. And the tube and the cabinet together would resonate at frequencies above and below the range of human hearing, so you wouldn't get any peaking from resonance, but yet at the same time it's going to invert the wave coming out So now when the speaker is moving this way and creating a pressure wave, it's also creating a rarefication inside here, but by the time it gets out here, because of the resonance of the system, it's going to also be a pressure wave. And so that increases the efficiency, and if you do that right, you can also broaden the bandwidth of it. So that's your bass reflex box, very, very common. If you look at a subwoofer, very likely you will see a little tube in there, which is the reflex tube of a bass reflex speaker enclosure. Now, another type of enclosure that is actually not that common, but yet it is a passive radiator. In fact, I really don't know how common they are, but I'll tell you, I've looked at a lot of Bluetooth speakers that have this whole idea. So what we have here is another speaker cone in the same box. So here's speaker A and speaker cone. They should be pretty much the same, so let's try to make them look about the same. Anyway, this is basically a speaker with no voice coil. So here's our voice coil and our magnets, and there's just a speaker cone. And if we get the resonance of the box just right and the resonance of this speaker cone just right, once again, it was a lot of trial and error when this was invented, but now it can be computer designed. We get this speaker coming out, producing a pressure wave. Of course, it's producing a rarefication in here, but because of the resonance in here and the resonance of that, just like the tube and the bass reflex speaker, they work together to cause this to be coming out at the same time. So this is not at all uncommon, because I've opened up a number of Bluetooth speakers. In fact, here's a picture of one right here. It's basically just a little rubber plug with a bit of heavier rubber in the middle that vibrates with the main speaker and acts like a passive radiator. So that's what you have there if you ever look inside a Bluetooth speaker and find, hey, that speaker has no driver. That's a passive radiator. There are some other types of speaker enclosures, but we're not going to go into those in detail because that's a specialty on its own. So let's move on and talk about typical speaker systems. You may have speakers that are full range speakers. That's pretty difficult to make. So most systems will use multiple speakers where you have one speaker that handles the bass, called the woofer, another speaker that handles the high frequencies, which is the tweeter, and maybe one that handles frequencies in between, called the mid-range. And it's not at all uncommon these days to have a subwoofer, something to handle the really low frequencies that can actually go below the frequency of human hearing, so you kind of more feel it than can really hear it. So let's take a look at how that is done, because we have to route those sounds to the right speaker. So what we have are two wires heading to our speaker, and those are carrying your full range of sounds, all the way from 20 hertz to 20 kilohertz. And we have in here a speaker, a woofer, we'll just do two of them, a woofer and a tweeter. And we could run the speaker wires to the tweeter and just split off and go to the woofer. But what's that going to do? The woofer is not going to react well to high frequencies. It can't move fast enough. So high frequencies that go into here are just going to be wasted as heat in the voice coil. Same thing's going to happen here. The tweeter can't handle the low frequencies, and so those are just going to be wasted as heat. So what we want to do is steer our high frequencies to the tweeter and our low frequencies to the woofer. Sometimes the most important thing is just avoid low frequencies to the tweeter, because that's where the biggest problem tends to be. The woofer is not so bad when it gets to high frequencies. It doesn't produce as much heat as the tweeter might. In fact, the tweeter could possibly be damaged if we put enough low frequency energy into it. So what we will do is simply put a capacitor in series with the tweeter. And it's called, of course, a crossover capacitor. We need a non-polarized capacitor, but usually this needs to be a big capacitor. So what do? We need a large value capacitor in a small package, but it can't be polarized, but like an electrolytic capacitor. So what do? Well, we take two electrolytic capacitors. So there's one axial leads, and there's the positive side and the negative side, and we'll just hook another one like this. And these are designed so that they can withstand the reverse polarity. So when the polarity is correct, For example, when the current is going this way, this capacitor has the correct polarity, so it's going to act like a capacitor. This one's basically going to become a short circuit. And if it's designed to handle that, then this will work. And when the current's going this way, we get the reverse. And this will be acting like a capacitor, and that one will be a short circuit. And in fact, you can buy capacitors designed like that, and guess what they look like? You're going to have a capacitor that has what looks like two positive ends. And that's a special crossover capacitor. Here's a picture of one. And you can buy these to put in series with your tweeter. And we know that what do capacitors do? High frequencies like to go through capacitors, but low frequencies don't. So that basically blocks the high frequencies from the tweeter. But to get a little more sophisticated, what we need is a crossover network, which is going to be a series of capacitors and coils that are high power filters that can handle the power going through them, that are going to direct the energy to the correct speaker. So we will have in there a crossover network that can get fairly complicated. There we go. So there's a signal coming in. We get the high frequencies to the tweeter, the low frequencies to the woofer, and if we have a mid-range, we have a special crossover that handles all three speakers. So that's what you would probably have inside a small speaker enclosure, is a small woofer and a small tweeter and a crossover network to handle directing the energy to the right speaker. Now, a lot of systems now have subwoofers, and so what do we do there? Well, the subwoofer is a different entity, and so we are probably going to have a separate wire just to send to the subwoofer. And what's that going to be? It's just going to be an even bigger speaker. Not too much to say about that. Very commonly in bass reflex enclosures. So there's our subwoofer in its box. And the interesting thing about the subwoofer is at the low frequencies, you can't really tell where the sound is coming from. High frequencies at your tweeter, you can hear where the sounds are coming from. But the subwoofer, or even some of the sounds coming from your woofer, you can't tell where they're coming from. So your brain processes sounds, and if it hears a high frequency sound coming from a tweeter, and a low frequency sound is associated with that, it's going to say, oh, that low frequency sound is coming from that tweeter. So it's very common to get speaker systems that have little tiny box speakers. I'm drawing that probably, is that maybe just a little small, that you would put on your bookshelves, and then you have a subwoofer somewhere else. So these handle your higher frequencies, and the subwoofer handles your lower frequencies. Bose makes some systems that are very commonly made this way. I have a number of computer speaker systems that are made this way too. Small speakers and then a subwoofer, and they sound surprisingly good for computer speakers. But even in your good high-end stereo equipment, especially like Bose, you'll find systems that have just two little speakers to put on your bookshelves, and those handle the high frequencies, and you hear the high frequencies, you say, yep, that sound's coming from somewhere between those speakers, and the subwoofer is making sound, and if that sound is coming there and the subwoofer sound seems to be associated with it, you'll think you hear the subwoofer sound coming from there. So your subwoofer can be put almost anywhere in the room, and it's big, and you might want to hide it somewhere, and so you put it wherever you want to. Some are made to fire horizontally like a normal speaker, but some are made to actually fire downward. That has to be engineered in its own right because there's complications of having that air pressure underneath it, but that is engineered into it so that your subwoofer can handle that. So if you have a system with a subwoofer, where do you put that subwoofer? Anywhere you want to, because you really can't tell where that sound is coming from. But you may have a system with multiple speakers in the boxes, and that's the same thing. You put them where you want to have the sound balanced, where you have your, let me move my hand in here, you have your right speaker and your left speaker. Of course, I'm backwards to you, but you put your speakers where you want the sounds to be in between those speakers, and then your subwoofer somewhere else. And of course, you may have a system that has surround sound. The most common surround sound system is what's called a 5.1 system. And what that means is that we have 5 speakers, 4 main speakers, just like you have your normal speakers in the front. You would also have 2 speakers in the back so that you can have sound anywhere in between those speakers. But if you're watching this on television, you want the dialogue and a lot of the sound effects that you are watching to appear to come from the TV screen. So here's our TV, and here's our speakers. Wouldn't I like to put my speakers on the wall like that? I have to have mine hidden in a cabinet, but that's the way it goes. I don't have the authority to put big speakers on the wall, so I have them down a little lower. But anyway, the ideal place would be on the sides of your TV. Some TVs actually have built-in speakers, but sometimes the sounds of dialogue are hard to locate. So what they'll do is put another speaker up here, your center channel speaker, very, very common, that would go on top of or below your TV to bring sounds such as dialogue into the center. And then you have your rear speakers in the back. And then what else do you have? Well, that's 5 speakers, 2 front, 2 back, 1 center speaker. That's that point 1 is. That point 1 is your subwoofer. So 5.1 surround is going to have 4 main speakers, center channel, and a subwoofer. And there's also, I think, 6.1 and 8.1. The most common, of course, is 5.1, but they do have systems with even more channels. I'm not sure how much that's needed. And of course, you have to have what you're listening to be in that same format. So 5.1 is the most common, and a lot of DVDs and Blu-rays come these days with 5.1 Dolby surround sound encoded onto the DVD. So if you found this useful and informative, please give me a thumbs up. It really gives the channel a boost, helps other people find these videos also. And be sure to subscribe and hit that little gray bell when you do, because then you'll get notified when I put up new videos. And to help me put these videos online, you can go to patreon.com/Vocatomy and pledge your support. A big thank you to my patrons. I could not make these videos without your support. And if you want to learn electronics technology, perhaps become a certified electronics technician, or get a jump start in your studies in electrical engineering, or just learn for some other reason, you can go to vocatomy.net and take my free course. Just go there, sign up. It's 100% free. So again, a big thank you to my patrons and other donors, and thanks to everyone for watching.